This video goes over a wide range of factoring examples. The first example that we have here is a simple trinomial. We're looking for two numbers that multiply to 28 and add to 11. Those two numbers are positive 7 and positive 4. The next one is another simple trinomial. Here we're looking for two numbers that multiply to minus 6 and add to 5. So multiplying to minus 6, we would have x plus 6 and then x minus 1. That's going to get us the correct middle term and the correct end term. Now here, this looks like a tricky trinomial, but what I would do first is I'm going to factor out the 3. So then I get x squared plus 2x minus 8. And now I can factor my resulting simple trinomial by looking for two numbers that multiply to negative 8 and add to positive 2. Those two numbers are positive 4 and negative 2. My next example, D, I'm also going to have to common factor, but this one's a little bit more involved. Now I'm going to take out 2m squared from each term. So that's going to leave me with m squared minus 3m, and then minus 36 divided by 2, which is going to be 18. So now in my resulting trinomial, I'm looking for two numbers that multiply to 18 and add to 3. So two numbers that multiply to 18 would be 6 and 3. I'm going to get negative 3 if my 6 is negative and my 3 is positive. Let's do another example here. Now I see a tricky trinomial. I'm going to check and see if I can common factor, and I can't, which is disappointing, but doable. I'm going to draw my lollipop and the stick, and then I'm going to write down my factors on the left side. 6 and 1, 1 and 6, 3 and 2, 2 and 3. And on the right side, I've got my factors of 10. So now I'm looking for two numbers that I can multiply together that's going to give me 19. Let's start. 60 and 1, no. 30 and 2, no. 1 and 10 and 6, no. 5 and 12, no. 30 and 2, 15 and 4. There's the magic number. So I've got 15 and 4. That's going to work as long as both of those numbers are positive. So I'm going to have 3x plus 2 and 2a plus 5. And I'm going to fix that. You should always factor using the variables that are given in the question. In this case, a. Moving on to example F, we have another tricky trinomial. I'm going to check and see if I can common factor. I can't. So I'm going to draw my lollipop and my stick. And then on this one, I'm going to write my factors of 8. And then on the right-hand side is where I'm going to flip my factors. I'm doing that because 3 only has one pair of factors, whereas 8 has 2. So by flipping my factors on my right-hand side, I have less options to consider. So I'm looking for numbers that multiply or that add together to get me minus 10. Let's start. 1 and 24, no. 3 and 8, no. 2 and 12, well, those ones are a possibility. 2 and 12. That would work if my 12 was negative and my 2 was positive. But that doesn't multiply together to give me positive 3. So let's check my last possibility here. 2 and 2 and 3 will give me 6, and 4 and 1 will give me 4, which is 10. So now, interestingly enough, two possibilities there. I'm going to use 2 and 4 and 1 and 3. That's going to work if 4 is negative and my 6 is negative. That way, my last two numbers are going to multiply to minus 3. Or excuse me, multiply to positive 3. And my middle numbers are going to add to minus 10. 4c minus 3. Let's do a couple more. So the next one here initially looks quite complicated, but I notice a C here and C's in all the other ones. And I also notice that my coefficients are all divisible by 3. So I'm going to factor out 3c from each term. This is going to leave me with 4c squared plus 5c minus 6. And now I have a tricky trinomial to factor, which is okay. So I'm going to draw my lollipop and my stick. On my left side, I've got 4 and 1, 2 and 2, 1 and 4. And on my right hand side, I've got my factors of 6. So now I'm going to multiply. I'm looking for two numbers that are going to add to give me positive 5. Let's start. 24 and 1. No. 8 and 3. Oh, that's a possibility. Let's take a look at that. So 8 and 3. Well, if 8 is positive and 3 is negative, I'm going to get to positive 5. And those two numbers are also going to multiply to give me minus 6. So reading horizontally, I get 4c minus 3 times c plus 2 as my factored answer. Now this next one here, again, initially looks complicated because the numbers are kind of big, but I'm going to factor out a 2 from each term and see what we get. So k squared plus 3, 108 divided by 2 is going to give me 54. Now I'm looking for two numbers that multiply together to give me 54 and that add to give me minus 3. Those two numbers are going to be 9 and 6, and that's going to be negative 3 if my 9 is negative and my 6 is positive. Let's take a look at example I. Initially looks pretty tricky because the numbers are so large. But what we can do is we're going to take a look at the lollipop method. So, and here I've got 12 and 1, 1 and 12, 6 and 2, 2 and 6, 3 and 4, 4 and 3. And then on my right hand side, I've got 1 and 15 and 3 and 5. Hopefully you're starting to see that the lollipop method is really just a glorified trial and error method. So I've got 12 times 15, well that's a big number, plus 1, that's not going to get me to 8. 60 and 3, also a no-go. 15 and 12, nope. Nope. Let's move on and check this. 2 and 6. So, and I'm going to check down here. So 10 and 18. Well, that is a promising candidate there. So that is going to work as long as my 10 is negative and my 18 is positive. So now I can read across horizontally and I get 2m plus 3 and 6m minus 5. Let's finish off with a couple more examples. First one, J, is I'm going to notice that I've got c squared here, d squared here. That's okay. I'm just going to factor it as if it was only c's and then put the d's in afterwards. So at the beginning, I'm going to start by writing my factors of 6. So 6 and 1, 3 and 2, 1 and 6, 2 and 3. On the right-hand side, I've got my factors of 10. Now I'm looking for two numbers to multiply that's going to give me 7. Two numbers that are going to add to 7. So I've got 6 and 10, no. 12 and 5, well that is a possibility. So I need them to add to negative 7. Well, if my 12 is negative and my 5 is positive, that would work. Those are also going to multiply to minus 10. So then I can read horizontally across 6c plus 5d. Remember, I have that extra piece. And then I've got c minus 2d as my fully factored form. This next example is kind of neat. I've got x plus 2 squared and then x plus 2 here. If I let x plus 2 equal m, I can rewrite my expression as m squared minus 4m minus 21. Now it's easy to recognize as a simple trinomial, where I'm looking for two numbers that are going to multiply to 21 and add to -4. These two numbers are -7 and +3. But my question was in terms of x, so now I'm going to put my x plus 2 back in to my brackets at the end, and this is going to simplify to x minus 5 and x plus 5. Let's do another example. So here, now I've got an x to the 4. So same thing. I'm going to say let x to the 4 represent m. So now I can rewrite my expression as m squared. M squared. Now, my first term, x to the 4, is really the same as m squared. Then I've got minus 13m plus 36. Again, I've got a simple trinomial. So m, let's see, multiplies to 36 would be 12 and 3. What multiplies 36? I guess would be 9 and 4. So I'd have minus 9 and minus 4. So now I can substitute back in my values. And unfortunately, this question isn't done yet. Now we've got two difference of squares. So I can factor this even further as x minus 3, x plus 3, and x minus 2, x plus 2. That is fully factored. This is not. Okay, two more examples. Here we've got x to the 4 minus 16. This is actually should be recognizable as a difference of squares. This is x squared squared minus 4 squared. So then when I go to factor this, I'm going to take the square root of my first term minus, the square root of my second term, so a minus b, and then I'm going to multiply by a plus b. Now that second bracket is fully factored, I can't go any further, but this one I can keep going into x minus 2 and x plus 2, and then x squared plus 4 in my fully factored form. This last one looks kind of complicated, but hopefully you remember back to our grouping examples where those first two terms have something in common, as do the second two. So I'm going to factor out 4x squared, and that is going to leave me with x squared minus 1. And then in my second one, I'm going to factor out 9. And I'm even going to factor out minus 9. So then we get x squared minus 1. Look at that. Those two brackets are the same. I can pull them out again. X squared minus 1 leaves me with 4x squared minus 9. And in true factoring fashion, we can keep going. X plus 1, x minus 1, and 2x minus 3, 2x plus 3. There is an example of lots of different types of factoring to help you with your practice.